Welcome to another session of Grade 9 Mathematics, Chapter 4, Linear Equation in Two Variables. Dear students, today in the second part of the chapter, we shall be discussing the solutions to the questions given in NCERT exercise 4.1 and 4.2. Now let us quickly get into the first exercise of the chapter, exercise 4.1. The first question: the cost of a notebook is twice the cost of a pen. I repeat, the cost of a notebook is twice the cost of a pen. Write a linear equation in two variables to represent the statement. And you can also look into the question you have been provided with a clue wherein it has been said that you can take the cost of the notebook to be rupees X and that of the pen to be rupees Y. Now, my dear students, as I had mentioned very clearly in the first part of the chapter, that we are expected to break the statements into small phrases. Now, if you could see into the question, it says cost of a notebook is twice the cost of a pen. Now, let me take the cost of the notebook to be rupees X and let me take the cost of the pen to be rupees Y. And we need to write a linear equation in two variables to represent the statement, which we can conclude that the required statement will be x is equal to 2y. And if I bring 2y onto the LHS, my final equation will be x minus 2y is equal to 0. So x minus 2y is a linear equation in the two variables representing the given statement. Now let us get into the next question. Here we have been asked to express the following linear equations in the standard form, that is ax plus by plus c is equal to 0, and indicate the values of a, b and c in each case. Okay, so in each of these 8 questions that has been mentioned, which you can see on the screen, we are supposed to first write or express them in the standard form, which is ax plus by plus c is equal to 0, and then mention what a, b and c represent in these given 8 equations. Let us start doing that one by one. The first one. The question is 2x plus 3y is equal to 9.35 and the bar on 35. Now, to represent this equation in the standard form, I'll have to bring everything on the LHS. So what would happen is the RHS would be left with nothing, so mention 0. So as part of the solution, if you could see on the screen, 2x plus 3y, which was already there in the LHS, yes. Now 9.35 bar, which was an RHS, is brought to the LHS. So plus 9.35 bar goes to the other side of the equal, it becomes minus 9.35 bar. So we have the equation 2x plus 3y minus 9.35 bar is equal to 0. And if I try to refer it to the standard form, which is ax plus by plus c is equal to 0, I can clearly state that a is equal to 2, b is equal to plus 3, and c is equal to minus 9.35 bar. Isn't it simple? Let's try with the second question. Here, the second equation is x minus y upon 5 minus 10 is equal to 0. Now, if you could see, this is already given in the standard form. Yes, I need not bring anything from the RHS to the LHS. So all that I have to do is write the standard form of linear equation, that is ax plus by plus c, and then state what does a, b and c represent over here. Now, if you could see x, which is part of the equation, that refers to 1x. Therefore, a is equal to 1, b is equal to minus 1 upon 5. Yeah, so y has a numerical coefficient of 1. So along with the sign, we mention that b is equal to minus 1 upon 5 and c is equal to minus 10. I hope that is clear to you all. Let us move quickly to the third equation. Minus 2x plus 3y is equal to 6. Now, as we did in the first two questions, we shall first bring everything on the LHS so that RHS is left with 0. So in the first step, what I shall do is, I'll write minus 2x plus 3y, and 6 from the RHS comes to the LHS. So 6 onto the LHS will be written as minus 6. So the equation is minus 2x plus 3y minus 6 is equal to 0. Now, if I compare that to the standard form, which is ax plus by plus c is equal to 0, I can clearly state that a is replaced by minus 2, b is replaced by 3, and c is replaced by minus 6. So, we have got the values for a, b, and c. Quickly, let's get into the fourth sub question, which says x is equal to 3y. Now, you could see that we don't have a constant as such directly mentioned in the question. But let me proceed with what we have discussed as of now, that is bringing everything on the LHS, yes, leaving 0 on the RHS. So my question was x is equal to 3y. 3y goes from the right hand side to the left hand side. Yes, so plus 3y goes to the left hand side becomes minus 3y. So my new equation is x minus 3y is equal to 0. Yes, I ask you to note again that we don't have a constant directly mentioned in the question. Now, if I try to compare it to the standard form, which is ax plus by plus c is equal to 0, I can clearly state that a is equal to 1, b is equal to minus 3, and my dear students, c, which is constant, is not mentioned here. So we'll take c to be equal to 0. I hope that is clear to everyone. If yes, let's quickly get to question number 5. Here, as you could see, which is very similar to the previous question, which is 2x is equal to minus 5y. I'll do the same steps, bring everything on the left hand side. So I'll have 2x plus 5y is equal to 0. And then all that I'll do is to compare it with the standard form of linear equation, which is ax plus by plus c is equal to 0. And as you can easily compare and tell me, a will be equal to 2, b will be equal to plus 5, and as in the previous case, here too, there is no constant mentioned directly in the question, so we'll take c is equal to 0. Very similar to question number 4. Yes. If you've understood it, then let's get to question number 6, which says 3x plus 2 is equal to 0. Now, everything is already on the LHS, but then you can find that there is no variable of y mentioned over here. Yes, and if you see to the standard form has ax plus by plus c is equal to 0. So there is a variable of x, there is a variable of y, and there is a constant. Now, if we could into the sixth question that we're doing, yes, we have a variable x, but then we don't have a variable y. So what I shall do is, I shall rewrite the question as 3x plus 0y plus 2 is equal to 0. And now compare it with the standard form, which is ax plus by plus c is equal to 0. And here you can easily state that a is replaced by 3, b is replaced by 0, and c is replaced by 2. I hope you have understood how to deal with the standard form, how to write a given equation in the standard form. Yes. Let's get to question number 7 and question number 8. So, as you can see over here, the question is y minus 2 is equal to 0. Over here again too, you will realize that you have a variable of y, You have a constant which is minus 2, but then you don't have a variable of x. Yeah. So what we shall do is y minus 2 is equal to 0 will be written as 0x plus y minus 2 is equal to 0. And then if I compare it with the standard form of the linear equation in two variables, which is ax plus by plus c is equal to 0, I can clearly state that a is replaced by 0, b is replaced by 1, and c is replaced by minus 2. In this way, we got the value of a is equal to 0, b is equal to 1, and c is equal to minus 2. I hope the first 7 questions that we have discussed clearly give you an understanding of how to refer the standard form of linear equation in two variables with the given equations. If that's the case, then let's quickly get to the last question, which is pi is equal to 2x. Now, as I did mention it last time around, with all the 7 questions, the first step is bring everything on the LHS. So pi is equal to 2x can be written as pi minus 2x is equal to 0. Now if I try to rearrange it and write with the variables coming first, then I can write it as minus 2x plus 5 is equal to 0. And over here again you will realize that you have a variable of x, but you don't have a variable of y. So the equation minus 2x plus 5 is equal to 0 can be rewritten as minus 2x plus 0y plus 5 is equal to 0. And then when I compare it with the standard form, which is ax plus by plus c is equal to 0, I can clearly state that yes, a is equal to 2, b is equal to 0, and c is equal to 5. Now, with these 8 questions been discussed, I believe you all have understood how to refer a given equation and compare it with the standard form and get the values of A, B, and C. That comes to the end of NCERT exercise 4.1. Let's quickly understand how to solve the questions given in NCERT exercise 4.2. Now, the first question is, which one of the following options is true and why? Now, which is the equation? Pi is equal to 3x plus 5. Now, the options that are given are that the given equation will have a unique solution. Option 2, that the given equation will have only two solutions. And option 3, that the given equation can have infinitely many solutions. What do you think the correct option could be? Dear students, we need to find the number of solutions for the linear equation, which is y is equal to 3x plus 5. Now, the correct answer will be infinitely many solutions. Why so? Because if I try to put the different values of x and try to solve the equation, I'll get different values of y. Let us look into an example. Say the equation is y is equal to 3x plus 5 as it is mentioned over here. If I try to put the value of x is equal to 0 and try to solve the equation. So the equation which is y is equal to 3x plus 5, all that I'm trying to do is replace the value of x with 0. Okay, and I try to solve it, I'll get y is equal to 5. So when x is 0, y is 5. Let me simply try to do it when x is equal to 1. So in the same equation, which is y is equal to 3x plus 5, this time x will be replaced by 1. And when x is replaced by 1 and you solve the equation, you get that y is equal to 8. Yes. So in the first two numbers that we replace, you may please note that when x was 0, I got the answer as y is equal to 5. And then when I put x is equal to 1, I got the answer of y is equal to 8. Now, let us try with one more number. Yes. So if x is equal to minus 2, What if the value of x is replaced by minus 2 in the equation? And if I try to solve it, I'll get y is equal to minus 1. So similarly, we can find infinitely many solutions by putting the values of x. Yes? So as you could see on the screen, the first solution was 0 for x, that is 0 comma 5. The second solution was 1 comma 8. The third solution that I got was minus 2 comma minus 1. In this way, for the given equation, that is y is equal to 3x plus 5, we can have infinitely many solutions. Now, if you have understood what solutions actually refer to, then let us try to find the solution to question number 2, which says write 4 solutions for each of the following equations. Now, you have been given 3 equations and you are supposed to find 4 solutions for each of these equations. Let us get to the first equation, which is 2x plus y is equal to 7. Now, if you could recall what we did in the first one, we referred to those numbers as solutions, wherein if I replace the value of x, I was getting a value of y. A similar approach shall be followed to get the solutions, the 4 solutions for the 3 given equations. So the first equation is 2x plus y is equal to 7. Now, for the simplification of the calculation, what I shall be doing first is I shall write 2x plus y is equal to 7, which is the equation, can be rewritten as y is equal to 7 minus 2x. And then all that I'll be doing is replace the value of x with different numbers. I could put the number 0, I could put positive integers, or else I could also put negative integers or say fractions. Okay, now as you could see, to begin with, I put the value of x is equal to 1 and I try to solve the solution. And when x was equal to 1, what answer did I get for y? 5. So 1 comma 5 is a solution for the equation 2x plus y is equal to 7. Every time the x coordinate is written first and then the y coordinate. And hence I did mention 1 comma 5 as a solution for the equation 2x plus y is equal to 7. Now, since we have been asked to find 4 solutions for each of the equations, let us try to put a few more numbers for x. Say if x is equal to 2, that is replacing x by the number 2, and you solve the equation, you get that y is equal to 3. Now, so what can we conclude? 2 comma 3. 2 which is the x coordinate and 3 which is the y coordinate is a solution for the equation 2x plus y is equal to 7. Similarly, you can put 2 more values of x and then get the values of y respectively. And then conclude that these are the 4 solutions for the given equation. I have put the value of x as 3 and 4 and got the answer of y as 1 and minus 1 respectively, which you can see on the screen. I hope now you are very much aware to how to find the solutions for a given equations. Yes, if that's the case. Let's get into the second question. Here, the second equation is 5x plus y is equal to 9. Very often, I have found children to replace the value of 5. My dear students, unless specified, kindly don't do that. So 5x plus y is equal to 9 is the equation. As I did in the previous question also, I'll just rewrite the question as y is equal to 9 and the variable pi x goes to the other side, it becomes minus pi x. And all I shall be doing is replacing the value of x with 4 different numbers to get 4 different values of pi and hence to conclude them as the 4 different solutions for the given equation. So let us discuss the first 2 numbers that I put. Say if x is equal to 1. Okay, x is equal to 1. So the equation is y is equal to 9 minus pi x. Replacing the value of x by 1, I get y is equal to 9 minus pi. So the x coordinate is 1, the y coordinate is 9 minus pi. Yes, I say it again, kindly don't put the value of pi unless it is specified. So the first solution of the given equation is 1, comma 9 minus pi. Similarly, you can put the value of x as 2, 3 and 4. And as you can see on the screen, when you put the value of x as 2, the y coordinate is 9 minus 2 pi. If you put the value of x as 3, the y coordinate is 9 minus 3 pi. And then when you put the value of x as 4, you may get the value of y as 9 minus 4 pi. I repeat again, it is not necessary that you have to put the positive integers. You could put 0, you could put negative integers, you could put fractions also. Any rational number is welcome for the value of x and get the 4 solutions as been asked in the question. Let us quickly get to the third question, which is x is equal to 4y. Now, my dear students, x is equal to 4y. It's very simple. All that I shall be doing in this case is you can put the replace y also or say x. Yes. And as you could see on the screen, all that I did to simplify is replace the value of y by numbers. So if y is equal to 1, as you could see on the screen, if I solve the equation, I get x is equal to 4. So x is equal to 4 is the answer that I got when y was equal to 1. So the solution is 4 comma 1. The x coordinate is always written first and then the y coordinate. And similarly, what I did was I replaced the value of y with 2, 3 and 4 and got the value of x as 8, 12 and 16 respectively, as you could see on the screen. I'm not getting into the calculations for each of these solutions because all that you're supposed to do is put the values and solve it. So for this particular given equation, the solutions are 4 comma 1, 8 comma 2, 12 comma 3 and 16 comma 4. So these are the 4 solutions to the equation x is equal to 4y. Now, the third question of the exercise asks us to check which of them are the solutions of the equation x minus 2y is equal to 4 and which are not. Okay, so the equation is given x minus 2y is equal to 4 is the equation and we have to check. We have been given 5 options and check which of them are the solutions or not. Quickly, all that we have to do is put the value of x and y, which is already mentioned. So if x is equal to 0 as mentioned in the question and y is equal to 2, and let me replace the values. If I get the LHS and RHS to be equal, which is not the case over here, okay? So if I get the LHS and RHS equal, I can conclude that the given solution is a solution of the equation. And as over here you can see that 0 comma 2, that is x is equal to 0 and y is equal to 2, when replaces x and y, I'm not getting LHS and RHS to be equal. Hence, I will conclude that 0 comma 2 is not a solution of the equation. Let me try with the next number, which has been mentioned, 2 comma 0. That means x is equal to 2 and y is equal to 0. I'll do the same thing, replace the value of x by 2 and y by 0 and see if my LHS and RHS are equal. As you could see over here, in this case too, LHS is 2, RHS is 4, which is not equal. Hence, I will conclude that 2 comma 0 is also not the solution for the given equation. Let me try with the third option that has been given, 4 comma 0. I replace the value of x by 4 and y by 0 in the equation. And here you can see that the value on the LHS and the values on the RHS when solved are equal. What does that mean? If LHS and RHS are equal in this case, we can conclude that 4 comma 0 is a solution for the given equation. Likewise, you can do with the fourth question, wherein x is root 2 and y is 4 root 2. You can go through the calculations that are done on the screen, and you can see that LHS when solved gives you minus 7 root 2 and RHS when solved gives you 4. Are they equal? No, they are not. So LHS is not equal to RHS in this case. And hence, we shall conclude that the given coordinates, that is root 2 and 4 root 2, is not the solution of the equation x minus 2y is equal to 4. Likewise, for the fifth one, the x coordinate is y coordinate is also 1, x and y are given as 1. All that you're supposed to do is replace the value of x and y, go through the calculations, you will find it again in this case too, LHS is not equal to RHS. LHS is minus 1 and RHS is 4. So what can we conclude? That 1 comma 1, the fifth option, is not the solution for the equation x minus 2y is equal to 4. I hope you all have understood how to conclude whether the given option is a solution of the given equation or not. This is the last question of the exercise 2.3, the last question of this part of the video, wherein you have been asked to find the value of k if x is equal to 2 and y is equal to 1. Again, you have been given the value of x is equal to 2 and y to be taken as 1. All that I shall be doing is replace the value of x and y as mentioned in the question in the given equation. So 2x plus 3y is equal to k. X is replaced by 2, y is replaced by 1. As you could see, solve it wherein I get 4 plus 3 is equal to k, 4 plus 3 is 7. So 7 is equal to k. So I can conclude over here that the value of k in this particular equation is equal to 7. So my dear students, I hope you have learned in this second part of the chapter how to find or how to relate a given equation to the standard form of linear equation in two variables, how to find the solutions of a given equation, and how to check whether the given options are the solutions of the given equation or not. On this note, we'll end up the chapter or the second part of the chapter over here. Take care of yourself until we meet next time with the next part of the chapter. Thank you.